For Calculus 3.2 Day 1, we're going to look at logarithmic functions because we just were talking about exponential functions, and logarithmic functions are inverse functions of exponential functions. And so it makes sense that we're going to go ahead and start those here. Basically, you learn multiplication, you learn how to undo multiplication by dividing. You learn how to square numbers, you learn how to unsquare them by taking square roots. They undo operations. Well, basically, you exponentiate. Now we're going to undo that by taking the logs. They are inverse operations. And so we're going to be recognizing and evaluating logarithmic functions with base A, graph them, and evaluate natural logarithms, and do a little application of those. So definition of a logarithmic function with base A for x greater than 0, a greater than 0, and a not being 1. Y equaling log base A of x is true if and only if x is equal to a to the y. They are inverse operations. And this function is read log base A of x. That's the logarithmic function with base A. So right here we have evaluate each logarithm at the indicated value of x. So this means what is y if x is 16? And so really it is what is the exponent on 4 so that 4 raised to that exponent will be 16. If we rethink of this as your base is 4, that exponent is your output, equals that argument of 16. What does y have to be so that 4 raised to that power is 16, and y has to be 2. So this is 4 to what power is x? And 4 to the second power is 16. So it is y equals 2. So right here, I want f of 64. That's log base 2 of 64. Or I'm thinking y is log base 2 of 64. Remember that output of the logarithm is an exponent. So this is 2 to what power is 64? It is 2 to what power is 64? And 2 to the 6th is 64. So y is 6. And there you have it. All right, for part C. Then this is, what is f of 1? Log base 5 of 1. It is 5, or I can write it y is log base 5 of 1. It means 5 to what power is 1? This is 5 to what power is 1? And that would be true if y was 0. Something to the 0th will always be 1. So right here we have in dy is equal to log base 3 of 1 over 81. So this is 3 to what power is 1 over 81? Well, 3 to what power is 81 is 9 squared. Or that is 3 to the 4th. Because 9 is 3 squared, 3 squared squared is 3 to the 4th. And so I have 3 to the y is 3 to the negative 4. Right? 1 over 3 to the 4th can be written as 3 to the negative 4th. So it is when y is negative 4. That is your output. Your output is the exponent that you need to raise 3 to get that value of x. So use a calculator. And so when you have log here, the base is, it's a common log with base 10. So when it's written like this and there's nothing in there, it's an understood base of 10. And so if you go to your calculator, you want to pick that log function. And so if I go to Desmos here, and I have come from where I just changed to the function mode, and in function mode there is a log. And so log of 2, there's log of 2 to 3 decimal places, 0.301. And then go to the function, and I've got log of 0.2, negative 0.69, and then use rounding rules, negative 0.699. And then log of negative 4. I don't know what will happen here. Log of negative 4, undefined. Because if you go back to the rules, the argument has to be greater than 0. Back here, x has to be greater than 0. And that has to do with, these are inverses of exponential. And on exponential, the domain is all reals, and the range is 0 to infinity. Well, logarithms are reflections over the line, or line y equals x. They're inverses, and they look like this. And domain and range switch. So this is exponential, and this is logarithmic. And so the domain is 0 to infinity, and the range goes from negative infinity to infinity. So this follows the y-axis and just goes down. And so the domain is just 0 to infinity. So that argument inside the logarithm has to always be positive. Logarithm inside there argument has to always be positive. So C is not possible. It does not. It's log of negative 4 is not possible. Does not exist. And on these other two, we had f of 2 being log of 2 to 3 decimal places, 0.301. And then f of 0.2 is log of 0.2, which was approximately negative 0.699 using normal rounding rules. Now, some properties of logarithms that you're going to want to know. If you see that the argument is 1, the exponent on the base would have to be 0 for that to come out to be 1, because a to the 0th is 1. If the argument in number 2 matches the base, well, that base to what power will be itself? It's 1. Your answer is 1, because a to the first is a. And if the argument is that base raised to some power, then that exponent is x. And then this is important, that a log base a of x, when this and this match and the coefficient of this is 1, then the output, this is an a by the way, the output of that is the argument of x. And then this right here is called the one-to-one property. It's just simply if you have the same log with the same base, the only way they're going to be equal is if their arguments are equal. X and y are called the arguments. So if you have that set up, then I know that x must be equal to y for those to be equivalent. All right, so simplify without a calculator. And so this is really log base 9 of 1. When you see that argument is 1, the output of that is 0, because 9 to the 0th is 1. It's the base to what exponent gives that argument of 1, and 9 would have to be raised to the 0th. And then right here, we have a square root of 11 and square root of 11. And this is the idea that log base a of a is 1. When the base and the argument are the same, then this must be just 1. Root 11 to the first will be root 11. And then when you see this base matching this base and that coefficient is 1 on the logarithm, then the answer to that is the argument of 30. All right, example 4, use the one-to-one property. The log base 5, log base 5 are identical, so the only way that these are going to be equal are if their two arguments are equal. So y just must be 16. Some people think you're dividing out log 5. That is not true. This is not true. Some people think, oh, you can divide by that. It's a symbol. It's not a, and they think that that's what's happening. No, 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 no. That is not what's happening. You can't divide by that symbol. Yeah, it's just that the only ways they can be equal is if their arguments are equal. And so in part B here, this is an understood log base 10. This is an understood log base 10. So these are matching. The only way they can be congruent are if their arguments are equal. So I can set up 4 minus 3x equal to x plus 2. Subtract 2, add 3x. And x is 2 divided by 4, or 1/2. And then in part C, again, the log base 3 are the same, so the only way that these are going to be congruent are if these two arguments are equal. So I'm going to set up x squared plus 4 must equal 29. So x squared is going to be 25. And so as I solve, I get plus or minus 5. And that will work as long as that's in the domain. And a negative 5, if I square it and add 4, I do get a positive number in there. So yes, they both work, and those are my solution. I need both of those. Moving on, natural logarithms are when we have a base of e. So when we had common logs, y is equal to log base 10 of x, we just wrote y is equal to log x. It's an understood base of 10. And now we have natural logarithms. And that is when the base is that e. And we're not going to write it like that. It gets its own, it's y is equal to, it's an ln(x). People see this, and I don't know, they think it's an I. It's not an I, it's an L. It's an L, natural log of x. And so this has an understood base of e, an understood base of e. So these are not the same. Common logs have a base of 10, natural logs have a base of e. And so you need to know the difference in notation. Those are two special notations where we don't show the base. And so example 5, use a calculator to evaluate. So this is f of 73.25. And we'll go ahead and go to 3 decimal places. And so this is just natural log of 73.25. And for part B, it's just going to be replacing with 0.3. So it's going to be natural log of 0.3. And so if I go to that Desmos calculator, I can go ahead and go to that function e to the, or actually I don't want e to the x, that's my fault. Natural log. And natural log then of, sorry, got the numbers, 73.25. 4.294. And then if I go to the function, natural log, and I have a 0.3, negative 1.2 negative 1.204. So back here, this is going to be 4.294. Again, know your calculator, know how to evaluate, make sure that you do. This is negative 1.204. And just as a reminder, that means e, remember the output of a logarithm is the exponent. So e to 4.294 is approximately that 73.25. And this means e to the negative 1.204 is approximately 0.3. Just that's that inverse relationship to those. So simplify without a calculator, use properties. You want to just know these. It's important to get these in your head as you move on to upper math because it's an expectation that you just know these. And so right here, this is the case where when you have log base a of a to the x, the answer is just x because the bases are matching. So x is the exponent you need to take a to get a to the x. And right here, that base is understood to be e. So the natural log of e to the 1/2, e to what power is e to the 1/2? Your answer is that exponent of 1/2. And in part B, this is if I have a log base a of log base a of x, where this coefficient is 1 and these bases match, the output of that is x. So in this case, this is an understood base of e, so these bases match, so the output of this is just 8. And in part C, by the way, the decimal is just part of the problem. It's not, it's not 0.15, it's just 15 natural log of 1. Well, natural log of 1 is 0. E to the what power is 1 is 0. And so this whole thing evaluates out to just be 0. This means e to what power is 1. And e to the 0th is 1. And in part D, I can think of this as 1/6 natural log of e. So making use of structure to change it to something that might be more helpful. And this right here, this piece is e to what power is e? And the answer to that is 1. So this is 1/6 times 1, and the answer is 1/6. Can't seem to write that. So I encourage you to know those properties. I'm going to come back up here and just kind of write them. We had them on the first page with bases other than e. So for the natural log function, the natural log of 1 is 0. The natural log of e to what power is e? 1. And the natural log of e to the x is just x. And e to the natural log of x is x. So those are some of the functions that you want to know. And again, this one's because e to the 0th is 1. This is because e to the 1st is e. And this is just e to the x is e to the x. So those are just some properties that you want to know. And they parallel the ones that we had up here with bases other than just e. There you have it.